Hello everybody, this is my another FPGA project which is a frequency counter. Here I have given external signal input to the FPGA and it tells the frequency of external signal, okay, on 7 segment display. Here's the DE1 board and here's my frequency generator circuit, okay. I have interfaced the output, the frequency generator to the FPGA through the SMA connector on DE1 board, okay. You can also connect it to general purpose IO pins, there is no problem. Just connect the ground to the ground of FPGA, okay. Connect the ground of frequency generator circuit or external circuit to the ground of FPGA circuit, okay. Now let me explain you the frequency generator. This is the frequency generator circuit. I am using Q5 as a frequency generator and this is a stable motive vibrator, okay. Here the R2 and C value, that is resistor and capacitor value, determines the frequency to be generated, and R1 value when change, it will change the duty cycle of the circuit, that is a duty cycle of the wave, okay. So now let's go to our frequency generator circuit. Now here I have connected an LED at the output of frequency generator so that we can see output, and I have set R2 resistance to 22k and capacitor to 10 microfarad and duty cycle resistor to 680 ohms, okay. So by calculating this value theoretically, we get the frequency value as from this website. Here I have entered the capacitor value, here the R2 resistor value, and here R2 resistor and here R1 resistor, okay. Then calculating, we get 3.22 Hz. Before actually measuring the frequency from external board like a frequency generator, I have generated a frequency internally in FPGA and I have generated 8651 Hz, that is 8.6 kHz frequency using clock divider. Now let's check whether it measures it accurately or not. So it is quite precise that it is measuring 8.649 kHz and that's good, it is working well, okay. Now let's measure the external. The board is ready now and the input frequency is given through the SMA connector on D1 board. The input frequency is set to 3.22 MHz now. Okay. Now let's run the code. Okay, the code is on FPGA. Let's start the process. So the 3.22 value is rounded up to 4 Hz and the frequency measurement is correct. Now let's change the resistor R2 value to 3.3k. The R2 value is set to 3.3k now. Let's check the theoretical value of resistor frequency. 3300. Okay, so the calculator value will be 19 Hz. So it should show near about 20 Hz or 19 Hz, or let's check what value it shows. So it's showing 19, that is the rounding up of 19.82. I don't know why it does that, but it shows near about accurate value, okay. Now let's check a bit higher frequencies. Let's go to 22k. I have made resistor value to 2.7k and capacitor value to 1 microfarad, and let's check what the theoretical calculation shows. So they are saying that the frequency should be 237 Hz. Now let's check it on board, that is what practical frequency it generates. Okay, the 555 is generating 184 Hz. So that's normal because there are practical errors also inside 555. But at lower frequency is showing a good result, okay. So please support me, visit my new website VHDLcodes.com, and thank you.